Hello friends, welcome to the session, continuation of power electronics. Still now we've seen so many converters, that is what exactly AC to DC converters and DC to AC converters, AC voltage controller and cycloconverter. This is one more converter in power electronics, that is the DC to DC converter, that is choppers. This one very important concept for any competitive point of view, and this is the 5-star concept for GATE point of view. Okay. Then before going to according to syllabus, first I will give some introduction. Then you go for according to syllabus in the DC to DC converter. Okay. See, this mainly this DC to DC converter is also called, generally this DC to DC converters are called SMPS, or this DC to DC converters is also called choppers. Is also called choppers. When the DC to DC converters are called SMPS and when the DC to DC converters are called choppers. If the DC to DC converters are used for low power applications, then it is called SMPS, that is switched mode power supply. If the same DC to DC converters are used for high power applications, then it is called chopper. I think you've seen SMPS in the CPU application. Then we can say that SMPS is one of the DC to DC converter. Then we can say that SMPS fed CPU, but we cannot say that chopper fed CPU. Even though it is a DC to DC converter, we cannot say that chopper fed CPU, but we can say that SMPS fed CPU, because where DC to DC converters we are using for low power application. Similarly, this DC to DC converters are also used for to control the DC motor. Then with respect to DC motor, then those converters, then how to say that it is chopper fed CPU. It is not chopper fed DC motor. It is not SMPS fed DC motor. That means if the DC to DC converters are used for low power application, then it is called SMPS. If the DC to DC converters are used for high power application, then it is called chopper. But point to remember, the main motivation of developing the DC to DC converters is for SMPS application. Then after that, you have so many applications on the DC motor, like that so many other applications also there. The main motivation of developing the DC to DC converters is for SMPS application. Why I am telling like this statement means, we know that for CPU, what is the supply we are using? Even the external we are giving AC supply, but internally we are using only DC supply. What is the rating of what is the voltage required for operation of CPU? Because internally CPU means, internally we are using the ICs. ICs means how much voltage it requires, plus or minus 1.5 volts, plus or minus 2 volts, plus or minus 3 volts, like that. But externally for CPU we are giving 230 volts 50 Hz AC supply now. But internally we are using plus or minus 1.5 volts, plus or minus 2 volts. How it is possible? That is possible because of the DC to DC converter. We are converting 230 volts 50 Hz. By using step down transformer, we may step down up to 50 volts or 30 volts. That 50 volts AC is converted into 20 volts by using any inverter circuit. But that 20 volts DC is again you want to convert into 1.5 volts DC. How it is possible? Because of the DC to DC converter. That's why what I am telling, the main motivation of developing the DC to DC converter for SMPS application. After that, we have so many applications in the drive. Mainly for control of DC motor, we are using the DC to DC converter. Okay. Then in some other applications means, nowadays in battery operated vehicles also we are using this DC to DC converter. Battery operated vehicles means, for example, if you want to increase the speed or decrease the speed, battery means fixed DC. If you want to increase the speed or decrease the speed means we want to variable voltage. That means if you want to convert fixed DC to variable DC means compulsory we can use a DC to DC converter. Like that so many applications are there. Okay. But first we will see what is the definition of DC to DC converter. Mainly our analysis is not for SMPS. According to our syllabus, mainly concentrate on the chopper. We don't have any syllabus on the SMPS, mainly in GATE syllabus. But in IS syllabus, there is some SMPS applications also given. Okay, SMPS, based on SMPS also, some syllabus is given in IS. At the end, I will give the 1 or 2 circuits for SMPS also. But mainly for GATE point of view, for any other competitive point of view, except engineering service exam, mainly concentrate on the chopper. Okay. In general, again, this chopper is nothing but a AC link chopper. AC link chopper. AC link chopper. Another one is a DC chopper. A DC chopper. But we are studying the chopper is nothing but a DC chopper. We don't have any AC link chopper. But what is the AC link chopper means? Before developing the DC chopper is nothing but generally you take the DC chopper only. Don't take AC chopper. Okay. But before developing the DC chopper, in order to get the variable DC voltages, we are used AC link chopper. What do you mean by AC link chopper means? For example, available supply is fixed DC. Available supply is fixed DC. But we want to get the variable DC. For that, what we have done means we can use one inverter. Then what the inverter can do? Fixed DC is converted into variable AC. Then this AC is given to the rectifier. This is given to the rectifier. Or inverter can convert DC to AC. Whenever it is given to the mainly rectifiers means you take the phase control rectifier. Then what the phase control rectifier can do? This AC is converted into control DC. That is, fixed DC is converted into control DC. Then this is also chopper, but it is a AC link chopper. In between, input is DC, output is DC. We are getting AC. That's why it is called AC link chopper. But nowadays, this conversion we are not using because of 2 conversion stages, more conversion losses. It requires 2 converters. Then cost is high, conversion losses are high, efficiency is less. All these are the problem. That's why we have developed chopper. Chopper is nothing but a DC chopper. Then what the DC chopper can do means, which converts fixed DC to variable DC or control DC in a single stage conversion. We no need any 2-stage conversion. In a single stage conversion, it will convert. Okay. But our study is DC chopper. Chopper is nothing but you take the DC chopper, not the AC link chopper. Okay. Now I'll see what is the definition of the chopper that you run. Okay. We start with the chopper. What is the definition of the chopper? Okay, write down all of you definition. Okay. This is some introduction. Then we'll start with chopper. That is, how to define one of the definition for chopper means it is static power electronic circuit. Okay, note down all of you. It is static power electronic circuit. Okay, which converts fixed DC to control DC or variable DC, control DC in a single stage conversion. That means a chopper is nothing but it is a static power electronic circuit. Which converts fixed DC to control DC in a single stage conversion. That's why here we are not converting DC to AC. We are controlling fixed DC to variable DC or control DC. That's why the choppers is also called DC voltage regulator. It is not AC voltage regulator. These are the DC voltage regulator. DC voltage regulator. Because which converts fixed DC to control DC. There is no any conversion here, but it is a controlling. Okay, that's why these are also called DC voltage regulator. Or we also define like this, which transfers power from DC to DC. It is not transferring power from DC to AC. It is not transferring power from AC to DC. A chopper is nothing but a, or it is also defined like this. It is static power electronic circuit. It is static power electronic circuit which transfers parallelly, no, don't wait, which transfers power from DC to DC, power from DC to DC. Yeah, this is a definition of the chopper. Now we'll see what are the different types of chopper circuits are available. Now we concentrate on types of chopper. Types of chopper. The first classification is based on output voltage level. Yes, based on output voltage level. Output voltage level. This is the first classification. The choppers are classified into, one is, what are the types of choppers based on the output voltage level? Yes. One is step down chopper, or it is also called buck regulator. Another one is step up chopper. It is also called boost regulator. Third one is up down chopper. It is also called buck boost regulator. There is another type of chopper is also there, but you don't have any syllabus on this. Shook regulator. Like that, so many chopper circuits are available. One is step down chopper. Step down chopper. Note down parallelly, don't wait. Step down chopper or buck regulator. Buck regulator, or it is also called V to I converter. V to I converter. Different names. Step up chopper. Step up chopper. Step up chopper. Or it is also called boost regulator. Boost regulator. Or I to V converter. I to V converter. I to V converter. Then third one is buck boost or up down chopper. Up down chopper. Okay. Or it is also called buck boost regulator. This is buck boost regulator. Or V to I and I to V converter. V to I and I to V converter. The fourth one is Shook regulator. Here, this is one classification. These are the types of choppers based on output voltage level. Okay. The another classification is the second classification of choppers based on quadrant operation. Based on quadrant operation. Quadrant operation. The choppers are classified into, yes, what are the choppers based on the quadrant operation? Yes. Type A chopper, type B chopper, a type C chopper, type D chopper, type E chopper. Okay, these are the types of choppers based on the quadrant operation. This is types of choppers based on quadrant operation. But instead of type, in some textbook it is also given as a class. You take type or class, both are same. It is also called class A, class B, class C, class D, and a class E chopper. Okay, this is the second classification of choppers based on the quadrant operation. The third one is based on commutation. Based on commutation. Okay, based on commutation. The choppers are classified into, based on commutation, the choppers are classified into, one is voltage commutated chopper, voltage commutated chopper, voltage commutated chopper. Another one is current commutated chopper, current commutated chopper, current commutated chopper. S, load commutated chopper. Actually, these are the thyristor choppers. I told already in the discussion of commutation, introduction of commutation. Once we are talking about commutation, means the circuit must be a semi-control device. One of the semi-control device is nothing but a thyristor. That's why here I am telling that voltage commutated chopper means this chopper consists of thyristor is the switch. That's the meaning. Understood? That's why this chopper is also called thyristor chopper, because we are using the commutation. But if it is a BJT, MOSFET or IGBT, no need of any commutation. Once we are talking about commutation, means the circuit must be consist of which device? Semi-control device. One of the semi-control device is nothing but a thyristor. Okay. Load commutated chopper, Jones chopper, Morgan chopper, next AC chopper. These are the types of choppers based on the commutation. The fourth one is multi-phase chopper. Based on application, the fourth classification of chopper is nothing but a multi-phase chopper. Okay, these are the different types of chopper circuits we are using. But according to latest GATE syllabus, this is only the GATE syllabus. In the syllabus, it is mentioned only buck regulator, boost regulator, buck boost regulator. But in the olden GATE, in the old syllabus, all these concepts are there except this one. Up to this, concepts are given. But in IAS point of view, up to this it is important. In IAS point of view, up to this important. But even though GATE syllabus is only these three topics is mentioned, but questions are framing even based on the types of choppers based on quadrant operation, and questions are framing based on voltage commutated and current commutated chopper also. And in 2018, based on the multi-phase chopper also questions are framed. That's the reason why, even though syllabus is this, but you have the knowledge on the total concept, then only you can solve the any competitive exam question. Okay, that's why concentrate on all these topics. But we don't have any questions still now in any competitive exam based on load commutated, Jones chopper, Morgan chopper, AC chopper. That's why in detail up to current commutated chopper and multi-phase chopper in detail I will explain. For any competitive point of view, that will enough. But for load commutated, Jones chopper, Morgan chopper, AC chopper, just whatever the points in future, if may ask that, then what are the points you concentrate? That only I will explain. Okay. But remaining topics in detail I will explain. Understood? Okay. Then First we will start with the types of choppers based on the output voltage level. That is nothing but a step down chopper. See, one simple concept I want to explain here. What is the need of this DC to DC converter? I given in application point of view. Then what is the fundamental need of this DC to DC converter? This can be explained by using simple circuit. For example, let us assume that we are giving input voltage is 20 volts. 20 volts fixed DC is available. And it is connected to the some load. This 20 volts fixed DC is connected to some load. What is the basic need of this DC to DC converter that I am explaining? We have so many applications are there, no doubt at all. By using this circuit, I am explaining simple basic need. Input is fixed DC is 20 volts. Then it is connected to some load. But for this load, I don't want 20 volts, but I want only 10 volts. I want to apply only 10 volts. But available is 20 volts, but you want to apply only 10 volts. One method is you connect one resistor here in such a way that the value of resistance must be in such a way that the voltage across the resistor is 10 volts. Then remaining 10 volts will appear across the load. This is one method. But what is the drawback of this method? Because of this resistance, there is a power loss in the resistor. Once the power loss in the resistor, then there is a more power dissipation in the form of heat. There is a high temperature rises. And another drawback is the circuit will operate at less efficiency. That is the problem. This is one method. This is a conventional method. But we want to supply the 20 volts to 10 volts more efficiently with a less power loss. Then what we can do means, instead of using resistor, we can use one switch. By on and off control of this switch, this is one switch we are using. By on and off control of this switch, then we can apply the 10 volts to the load. Is it possible? Yes. For example, available input is fixed DC. This is 10 volts is available. Now what I am doing, I am controlling on and off of switch. In the total time period, I will turn on the switch for, let us assume that 10 milliseconds. Let total time of operation is 20 milliseconds. This is 20 milliseconds. This is on. This is off. What I can do means, on off is in our control. I will make the switch is on for 10 milliseconds, off for 20 milliseconds. Again on for 10 milliseconds, again off for 10 milliseconds. In the total time period of 20 milliseconds, on for 10 milliseconds, off for 10 milliseconds. Then what is the input voltage we are connected? Total is 20 volts. In the total 20 volts. Now what is the average voltage applied across the load, you tell me? For this type of waveform, how to calculate average value? So many times I told. Amplitude into on time by total time period. 10 by, what is the total time period? 20 milliseconds. Then how much you get? 10 volts we can get. That means without using resistor, just by using switch arrangement, we can control on and off of switch. By controlling on and off of switch, then we can apply the variable DC voltage to the load. Here switch is nothing but any power semiconductor device is used as a switch. We can use BJT is used as a switch, MOSFET is used as a switch, IGBT is used as a switch, GTO is used as a switch, SCR is used as a switch. Then by using the semiconductor devices, by controlling on and off of semiconductor device, we are controlling fixed DC to variable DC. Then this type of converter is nothing but a chopper or DC to DC converter. Understood? During this operation, in order to reduce the ripples in the load current, in order to reduce the ripples in the load voltage, during this operation, if there is any ripples are there in load current, and if there is any ripples are there in load current, in order to reduce the ripples in the load current, we can use one inductor. In order to reduce the ripples in the load voltage, we can use one capacitor. This is filter inductor, this is filter capacitor. Then the circuit is called regulator. Then the circuit is called regulator circuit. See the difference. What is the difference between the chopper and regulator? Here I am telling that step down chopper or buck regulator, step up chopper or boost regulator, up down chopper or buck boost regulator. Here what is the difference between the chopper and regulator? A chopper is nothing but without filter circuit, then it is nothing but a chopper. With the filter circuit, then it is treated as a regulator. But it may be chopper or regulator, formulas are same, no doubt at all. But only difference is, if you use with filter circuit, then it is called as a regulator circuit. Without this filter arrangement, then it can be treated as a chopper. That is the only difference. Remaining analysis and waveforms all are same. Okay, that point you remember. Okay, this is the basic need of implementing the DC to DC converter. In order to, instead of using resistor, this is the conventional method. But problem with the conventional circuit is more power loss. But this is power electronic circuit. Without using resistor, just by controlling on and off of switch, we can control the output voltage. Then this type of converter is nothing but a DC to DC converter. Okay. Now we'll start with the first concept is types of choppers based on output voltage level. That is step down chopper or buck regulator. Step down chopper or buck regulator. Okay. Then this is 5-star concept for gate point of view. This is 5-star concept. These choppers are very, very important. Okay, last 4 or 5 years, from 4 or 5 years, mostly the questions are asking based on this topic. The next important is this one. The next important is this one. And next important is this one. Okay. But in this, based on commutation circuit, I will discuss one concept of LC circuit and tank circuit. That is 5-star concept for gate point. In this concept, there is one concept is there, but the concept of LC circuit or tank circuit, that is very, very important for gate point. Okay. Then if you want to clear knowledge on the DC to DC converters, means concentrate on every circuit. Then we get the clear knowledge. Okay. Then first we will start with the types of choppers based on output voltage level. That is nothing but a step down chopper. Okay. Shall we start? Okay. Completed? Yes. Or buck regulator. The step down chopper or buck regulator, or it is also called V to I converter. Buck regulator. Yes. First to draw the circuit for step down chopper. And this is chopper or switch. Here we are connecting the freewheeling diode or diode. This is filter inductor. And this is the load. And this is filter capacitor. Let this is I now. Voltage across the load is same. This is L, this is C. The supply voltage is VDC. This plus minus. This is chopper or switch. Either chopper or switch. Yes. Where L is the filter inductor. To reduce the ripples in load current. Now don't parallelly, don't wait. C is the filter capacitor. To reduce the ripples in load voltage. To reduce the ripples in load voltage. Yes. Before starting the operation of this circuit, first you will see here chopper is nothing but here I am chopper or switch. Chopper or switch is nothing but any power semiconductor device is used as a switch. Either MOSFET is used as a switch, BJT is used as a switch, IGBT is used as a switch, GTO is used as a switch, SCR is used as a switch. Any power semiconductor device is used as a switch. But MOSFET is more preferable for SMPS application. That is for high frequency application. More preferable for high frequency application. This BJT, IGBT, GTO and SCR is preferable for medium and high power application. Medium and high power application. That is for chopper applications, these are more preferable. Chopper. But among all these devices, for chopper applications, GTO is more preferable. Among all these devices, for high power applications, SCR is preferable. But if you use BJT, IGBT and GTO, what is the advantage means? Here input is DC na? If you use input is DC, then if any semi-control device, it must require external commutation circuit because input is DC. But if you use BJT, IGBT, GTO, all these devices are fully controlled devices. Even though input is DC, no need of any commutation circuit. That is the advantage. But what is the problem with SCR? Advantage of SCR is, if you want to use for high power application, no other choice, compulsory you can select SCR. But if you use SCR, the complexity in the circuit is, in order to turn off this SCR, compulsory you can use one external commutation circuit. Once we can use external commutation circuit, then it becomes a thyristor chopper circuit. But what is the final conclusion I am giving here? If there is a medium power application or low power application, instead of going for SCR, better to go for this device. If it is a very high power application is there, then only go for SCR, because these devices cannot be used for high power application. But SCR can also be used for low and medium power, no doubt at all. But problem is, if you use SCR, it must require external commutation circuit because input is DC. That's why do go for SCR? Then select BJT, IGBT or GTO, because no need of any commutation circuit. If choice is not there, then only go for SCR. If choice is there, then go for these devices, fully controlled devices. Because if you use fully controlled devices, no need of any commutation circuit. Okay, that is the selection. And another point to remember, here this circuit I will explain for both continuous and discontinuous mode. First, the total main analysis I will give for continuous mode. But one or two formulas I will explain for discontinuous mode. Okay, continuous mode means I am assuming that constant current we are supplying to the load. With that assumption only I will explain. Main analysis is very important for competitive point of view, continuous mode. But one or two formulas how to write for discontinuous mode also I will give. Understood? Another point, if any questions are framing based on the circuits means, sometimes they don't mention it's a buck regulator or boost regulator, step down chopper or step up chopper, like that they don't mention. The questions are asking like this. For the chopper circuit shown in figure, calculate average output voltage, calculate RMS output voltage, calculate peak to peak ripple current, like that questions are framed. Understood? If it is asked like that, then given circuit, first you identify given circuit is what type of chopper. Then only you can apply the formula according to that. Then by seeing the chopper circuit, how to identify? It is a buck regulator, is it a boost regulator, is it a buck boost regulator? You remember this point. If the inductor is at load side or diode across the load, then it is a buck regulator. If the inductor is at source side, then it is a boost regulator. If the inductor is at middle, then it is a buck boost regulator. Like that you ready to. Why I am telling this statement is, during solving, framing of the questions mainly in GATE also, they don't mention the type of chopper. They will give some data or they will give some circuit. By seeing that circuit, how to identify it is a step down chopper or step up chopper or up down chopper means, this point you remember. If the inductor is at load side or diode across the load, for step down chopper, two observations are there. You can identify by using this diode or by using the inductor also. If the inductor is at source side, then it is a step up chopper. If the inductor is middle, then it is a up down chopper. Like that you remember. Here, another point. Sir, how to identify is it continuous mode is operating or discontinuous mode is operating? Yes. In the problem it is mentioned that it's a ripple free current, constant current, large inductor, like that it is mentioned that, then you take a continuous mode. In the problem it is mentioned that it is a discontinuous mode, then you take the discontinuous mode. But it is not mentioned that it is a ripple free current. It is not mentioned that it is a constant current. It is not mentioned that it is a discontinuous mode. Then how to identify it is a continuous mode or discontinuous mode? Yes. If data is available to check the continuous mode or discontinuous mode, then we can check the condition and identify is it a continuous mode or discontinuous mode. If the data is not available to check is it a continuous mode or discontinuous mode, then you take the continuous mode only. Generally, our analysis is based on continuous mode. Discontinuous mode is special case of analysis in our study. Understood? Okay, like that you can identify is it a continuous mode or discontinuous mode. Understood? Another point to remember, throughout analysis of buck regulator or boost regulator or buck boost regulator, I will use one is volt second balance. Volt second balance. Volt second. All these circuits are analyzed by using volt second balance. One is, what do you mean by volt second balance means? Voltage across the inductor during on time. VL on into T on. VL off into T off is equal to 0. And I also use to derive the different parameters in the analysis of this circuit. I will use volt second balance, and other one is ampere second balance. Ampere second balance. Ampere second balance. What the ampere second balance means? IL on T on plus IL off into T off is equal to 0. We can explain the circuit analysis is based on volt second balance or ampere second balance, or the circuit can also be analyzed by using energy balance. Energy balance. Only by using energy balance also we can explain. What do you mean by energy balance theory means? Energy stored by the inductor equal to energy released by the inductor. That means the analysis is based on the stable operation, not for unstable operation. If any circuit is consists of inductor, when the particular circuit is said to be stable operation means energy stored by the inductor must be equal to energy released by the inductor. Then only you can say that stable operation. So many times that I already told this point. Understood? Okay, that means mainly I will explain by using volt second balance and the ampere second balance. Different parameters are derived by using these two theories only, volt second balance theory and the ampere second balance theory. Understood? Yes. Now with this knowledge, now we'll start with what is the operation of this circuit. And another point to remember here, operation of Chopper circuit is nothing but a one time period of operation. I will explain operation for one time period. For next time period again, the same concept will be repeated. And our analysis is for one time period only. Every time I don't tell that for one time period like that, okay, I don't want to tell. But total analysis we are doing for only one time period. One time period is nothing but one operation is nothing but one on and one off. Chopper is on, what is the observation? Chopper is off, what is the observation? Then what are the different parameters we want to derive? That is under continuous mode. Initially I will start with continuous mode only. One or two concepts I will explain for discontinuous mode. But so many times still now in GATE exam or any competitive exam, most of the questions are framed only on continuous mode. But one or two times in GATE exam based on discontinuous mode only it is framed. But mainly concentrate on continuous mode only, how to analyze. But one operation is nothing but a one on and one off. Chopper is on. Here we don't have any positive off cycle and negative off cycle. You forget that one. We don't have any positive and negative off cycle. Input is fixed DC na. On and off is in our hand. Chopper is on, what is the analysis? Chopper is off, what is on? And I am explaining this concept by using any fully controlled device only. I am not discussing still now thyristor chopper. So that is separate concept. Here chopper is on, what is the analysis? Chopper is off, what is the analysis? Okay. Now we'll see in detail about this circuit. We'll start with in the next session. What is the analysis of this circuit? Clear? Concentrate. Okay, hold on. In the next session, we will continue with what is the operation of this step down chopper or buck regulator. Then what is the different performance parameters? What is the waveforms we are using? All these. Okay, thank you.